Hey, let's write the equation for the ellipse in standard form. Here's our directions up here. Let's look at them again. Write the equation for the ellipse in standard form. That's the h squared and k and all of that. State the center. Horizontal, vertical stretch factors. H equals V equals. Locations of the foci. That's the coordinate points, so we'll figure that out. Then graph the ellipse. Excuse me. My equation here is in general form, needed in standard form. Well, how do you do that? We need to complete the square. We're going to complete the square on the x's, complete the square on the y's, move that 236 to the other side, balance the equation out. So let's go. Zoom in a little so I can write. We're putting together those x's. Remember, when you are completing the square with 16x squared and negative 64x, you need to factor 16 out of both of those terms. When I do that, I get 16 times x squared minus 4x plus a blank. I also, with the y's, will complete the square, form a perfect square trinomial. Remember, both of those terms, you have to factor 25. If I factor 25, I have plus 25 on the outside times y squared plus 4y plus a blank. Make a perfect square trinomial. And I have to move the 236 to the other side. That makes this equal to 236 plus the number that I'm going to complete the square with, form a perfect square trinomial on the x's, and that number is times 16 to put in that blank. I'm going to also add a blank to do the same thing with the y's. Make a perfect square trinomial, take that number, multiply it by 25 as well for here balancing the equation. So those numbers, 4 makes a perfect square trinomial on the x's, 4 makes a perfect square trinomial on the y's. But 4 times 16 balances the equation, that's 64, and 4 times 25 balances the equation, that's a 100. Now, we need to factor this and factor that and collect like terms. Now my equation becomes 16 times x minus 2 squared plus 25 times y plus 2 squared equals 400. Your last step is to make this side equal to 1. To make that equal to 1, we have to divide 400 by 400, which means I also have to divide this part by 400 and that part by 400. If I divide all three by 400, then my equation will reduce. We have to take 400 and divide it by 16. It's not normal fraction reduction. 400 divided by 16, that's going to be 25. And 400 has to be divided by 25, that's 16. Then the 400 divided by 400 will make 1. Therefore, my standard form equation, x minus 2 squared over 25 plus y plus 2 squared over 16 is equal to 1. There's my equation. Standard form, the center, 2, negative 2. Horizontal stretch factor, 5. Vertical stretch factor, 4. Let's write that down. Remember, with the directions up here, we need to state the center, the stretch factors, then we'll find the foci. We'll graph it in between all of this as well. So my center will be located at 2, -2. Opposite from parentheses. 2, -2. That's where my center will be. My horizontal stretch factor. This fraction is everything on the x's. Shifting for the center, my horizontal stretch. So my horizontal stretch is 5. This is everything on the y's. My vertical shifting for the center and my vertical stretch factor. So my vertical stretch is 4, telling me that this is a horizontal ellipse because the stretch factor is bigger horizontally. Let's start the graph. If my center is at 2, -2, let's find 2, -2. Put a little mark there. My horizontal stretch, remember, let's look over here. Horizontal stretch is 5, vertical stretch of 4. Back to the graph then. Horizontally, I need to make a mark 5 units to the right, make a little graphing mark. 5 units to the left, make a graphing mark. 4 units to the top, because that was the vertical, and 4 units to the bottom. From there, form your ellipse. We've graphed it. The last part are the foci. That's the fun part. We have a focal formula to use. It's based on the original denominators of 25 and 16. We need to use the formula that the foci are located at plus or minus the square root of a squared minus b squared. 25 is a squared. It's always the bigger denominator. 16 is your b squared. Therefore, to figure out these numbers, this is equal to plus or minus the square root of 25 minus 16. That's plus or minus the square root of 9, which is plus or minus 3. Which direction? Well, your foci always go on the major axis. So the major axis is running horizontally. I need to take 3 units to the right, put a mark, and 3 units to the left and put a mark. Those are the 2 foci. So my foci will be located here and here. And my very last step is to state where those foci will be to answer the questions. If I add and subtract 3 from the x, that gives you these 2 coordinate points. And my foci coordinates will be at 5, -2 when I add 3, and when I subtract 3 at -1, -2. And now my answer is complete. There's everything.